I'm Joyce Hornady. You might say accuracy is my business. I make bullets.
You are listening to the Hornady Podcast.
Thanks for joining us and enjoy the show.
Hello, everybody. Thanks for tuning in on this episode of the Hornady Podcast. As always, Seth Swerzik, your host, and joining me to my left, senior ballistician Jayden Quinlan. Jayden, thanks for coming on.
Yep, absolutely.
Well, you're very needed in this podcast, and you know the ballistic study of podcasts that we've been doing has just been immensely popular.
Yeah,
a lot of good feedback, a lot of questions, a lot of people looking at things differently, and it's all been good. And we've got a guest on the show that was paramount in a lot of things that you've done and instrumental in a lot of our ballistic understanding. And yeah, I'm excited to get into this one because it transcends more than just our kind of what I'm going to say technical advisor into a book and a whole bunch of cool stories. So Jayden, if you would, please introduce our guest to the show.
Okay, thank you. Yeah, so our guest is Jeff Siewert. So I think everybody probably has like a guy they call. You know, you have a problem with something, right? You got a guy you can call.
Yeah.
Jeff has been that guy for me for many years, as well as Dave Emery, right? You know, Dave Emery was the senior ballistician here for a very long time, and I worked with Dave Emery for many years, which is how I met Jeff originally. Probably would have been like 2012 or 13 timeframe.
Somewhere in there?
Yeah, you came out and you taught a class. We used some software from a company that Jeff used to work for, and he came out to teach kind of an advanced user version of that class. And during that class, I kind of picked up on the fact that, he probably has a passion for ballistics. He's got to fire kind of like I've got to fire. And so we kind of just naturally, I think, connected on that level. And for years, I've ran stuff past Jeff, and he's helped me a ton. I think we'll talk about his book a little bit, which helped me a lot. I know you read it.
Oh my gosh. Yeah. Yeah. To diverge quickly into his book, and we'll talk about it more in depth. But for me, as my career progressed through Hornady, doing, the technical services stuff and kind of like you mentioned with Jeff, that you had that passion for ballistics and why and how and everything works. And I kind of had that too, only at a much more rudimentary level. And with Dave Emery's retirement from Hornady, you needed some help in the lab, and so I got to transition to dabble in that ballistics field. And from a complete novice standpoint, there's a lot you can learn on the job. And when I got that digital copy of what turned out to be Ammunition Demystified, there was so many answers in there. I had to read it several times over. There was a particular chapter in there that was well over my head that I read, I don't even know how many times. It was talking about case geometry and radial hoop strength and the nonlinear way that things expand, and that was like way over my head. But throughout that book, there were so many things that were technical in nature, complex in nature, that were digestible, that I was able to go, okay, now I can connect some dots. And it really made my job easier to do because I was understanding things at a more complex level. And the book, although there is a lot of complexity to it, it was in a way that I could understand it, and it was helpful, and it was almost, you could use it as a resource, almost as like a textbook, if you will. But it didn't
I still
read
do
like
to
that.
this day.
Yeah.
I'll go back and reference the book. Absolutely.
Yeah, so I need to jump on Amazon and get the paperback version because I've still got just the original one.
Yeah,
saved
it
to my
existed
phone.
as a like an ebook, right?
Right.
And for a long time, and now finally it's in print, which is great.
Yeah, well, it was again paramount to help me understand some stuff. But yeah, let's kick it over to Jeff here and talk about who knows what.
Well, first, thanks very much for having me. I really appreciate the opportunity to talk a little bit about the book and some of the experiences I've had over many years as a ballistics engineer.
What did your career look like, Jeff? Because you've got you've dabbled in the small cal world a lot, right? That's what we do here at Hornady. Most of our listeners are going to be familiar with small cal, right? Shoulder fired rifle or handgun or stuff like that. But you've done it all. You've done small cal, large cal, everything. I mean, kind of give us an overview of your career.
Yeah. So I started 1977, graduated college, woke up 5 weeks later. My butt was in Saudi Arabia. I spent 18 months over there working with the Saudi National Guard. Did a little bit of ballistics work over there. We had some questions about whether or not the ammunition had the muzzle velocity we thought it should have. Got back from there and started looking around for a job, and what popped up was a job in the ammo group. And it was like, well, I'll do this until it's not fun anymore. And I never left.
So what did you major in college?
I was a physics major.
Okay.
Physics major.
That explains a little bit.
Yeah. And so at GE in Burlington, Vermont, I was in the ammo group, and I got to work on a pile of really interesting things. Case telescope ammunition, 20 millimeter.
Mm-hmm.
I was kind of the Johnny on the spot for that, for a good chunk of it anyway. Some high velocity test fixture work. We're pushing, 300 gram projectiles out at over 5,500 feet per second.
Wow.
Oh, we do that all the time around here.
Oh yeah, we've got the electromagnetic railgun.
Worked on the M774 fuse development. That's currently in the 120 millimeter M830A1. Worked on a pile of different things, and like most guys, after a while, it's like, well, what else is out there? What other mountains are there to conquer? And so my boss had left a few years prior and started his own little company, and I stuck my hand up and said, "Yeah, if you're looking for folks, I'll join you," and I did. And it was kind of a no-brainer, just move down the street, and same benefits, better pay. What's not to like?
Yeah, win-win.
What's not to like, right? So for 30 plus years, and there I worked on, it was, like you said, everything from soup to nuts. In my career, I've worked on everything from 17 caliber air rifle pellets up to 8-inch howitzer, and almost everything in between. Worked on rockets, worked on all kinds of different things.
Wow. And you say worked on from a projectile standpoint, propellant, all things?
The whole smash.
Oh,
The only thing I didn't get involved with was primers.
Wow.
So worked on cartridge cases, case chamber interaction, worked balloting simulations, the dynamic interaction of a flexible projectile and a flexible gun tube. And a lot of what we've learned over the past, I'm going to say, decade or so, comes from some of that work that was done for a customer looking at targeting problems in a Gatling gun.
Wow.
So it's been really an interesting career. And am I sad to see it go? Yeah, in some ways, but I've still got my finger in. I'm working a couple of small jobs right now. So
Sure.
Even though I'm quote retired.
Yeah, you're still in the game.
Yeah, well, and that kind of knowledge that you get, from the formal education, and then just the decades worth of experience in propellants and design. And
I would like to say that I have had some just wonderful mentors over the years.
Sure.
Bob White, Wayne Hathaway, Alan Hathaway, brother, John Burnett, Bud Stearns, some really wonderful and talented people. That it's one thing to know something and be able to just spout it out, but having the patience to take the time to explain it to somebody, that's kind of a rare talent, I think. And I'm very grateful for having had that opportunity. The book is my attempt at doing the same thing without having to sit over somebody's shoulder.
Mm-hmm. That's really cool. Well, you describe how interesting all that work was in that career field, but to take some words from you from back in the day, I'm like trying to pull something out of him here. Aren't bullets just like little lumps of metal?
Yeah, so that was actually a comment from a very good friend. She's the wife of a guy who was our best man. And when I told her that I was going to have a job in ballistics, that was her question. And
she's not wrong.
She's not wrong. She's not wrong. No. I mean, if you're just an outsider, standing outside looking in, that's what it looks like, But if you treat them like little lumps of metal and you don't know any more about them, then the road to goodness is long and may not end in success. So, it's you have to really dig deeper. I mean, you tell somebody, oh, there's 3 forces acting on the projectile in 4 moments. Who knew? Who knew? I didn't know when I started.
Right.
So, I mean, projectile flight is just one facet of a very complex subject.
Yeah. Well, especially when you get into your depth of work, that it's not just the lump of metal flying, it's the interaction of the case and the propellant and the primer and that ignition cycle and the barrel and the chamber. And
it's really the interaction part where the rubber meets the road. I mean, okay, the bullets somehow left the barrel. Did you leave the cartridge case behind in one piece? Did you burn all the powder out? I mean, there are a whole pile of things that you really should be worrying about if you're on top of things.
Yeah. Well, why don't we, like you said in that kind of ballistic study we've done, we've definitely covered some topics, but there's some that we haven't even touched on, but are common out there.
Yeah.
And Jeff, I know, you'd be a great one to get your opinion on with your experience in this stuff. So like a common one that people think of is the brush bucking. Like I'm going to be hunting in a
heavy timber.
Yeah. And I want something that's just going to be able to smash right through something and hit right where I aimed. I mean,
yeah.
What's your take on that from your experience?
Well, it's actually covered in the book. So we once upon a time had an experience with a customer who was building 120 millimeter tank long rods. These rods are over 2 feet long. They're made out of heavy metal. They're about 1 inch in diameter, and they're cruising along at over 5,000 feet per second. So the test protocol for that particular cartridge, they have fly-through targets at 1 kilometer and 2 kilometer, and at 3 kilometers, that's where you get paid. So you have to have 10 shots out of 10 fired in the target, and they all have to be within a certain size. Okay, wonderful. Well, they fired 10 shots, and there's 10 imprints in the first target, 10 imprints in the second, and in the third, there's 9 imprints. Like, what the heck happened? So this would be roughly the equivalent of having a rifle that you could pile 10 shots into 1 inch extreme spread at 100 yards, and all of a sudden, you get a 14-inch flyer. What the heck happened?
Mm-hmm.
How did that happen? So we started making some numbers, and we just started asking questions of the test group. Is it possible that there was a rock stuck to the target? Oh, yes, absolutely. We had their cheesecloth. They called them cheesecloth. It's kind of woven fiberglass. They would lay them down in the dirt.
And then stand them up.
Bore sight on the 3 kilometer target, get the right drop, right? It's not much drop, but there is some. And then they stand them up and they fire through them. And so we said, well, what would happen if there was a 3/4 inch diameter rock stuck to the first target? What sort of flight path deviation would we get from that? We, in very short order had kind of an estimate for how much force was applied for how long, and where on the body of the projectile it would, be right at the nose. And we have computer codes that can tell us from a trajectory standpoint what sort of flight path deviation there would be. And it's like, yeah, that looks about right. And the customer said, well, that's really nice. Can you come with us when we talk to the customer about this? Sure. And we did. And the customer said, we'll buy the lot of ammo, but we better not hear that excuse again. So from my perspective, if a 9-pound long rod moving 5,000 feet per second can't fight off a crummy little rock, what chance do you have of bucking any brush with any rifle cartridge? Can you get lucky? Sure you can. Mm-hmm. But I wouldn't be taking the shot purposely to try to hit a branch and count on it going where I want it to go.
Yeah.
It just I've seen too many shots deflected from that standpoint. So I pick a spot, thread the needle.
Yeah.
thread the needle. That's the road to success in my book.
You heard it here. Bucking brush is a fallacy.
Yeah.
I don't care if it's a 30-30 with a 170 grain round nose.
Yeah, you can get it to work. I think that is important, is to acknowledge that idea exists for a reason, right? People have been successful in doing it. They've shot through brush and killed the buck just fine. But to your point, Jeff, there's more going on than you think.
Yeah.
Just because you did it once doesn't mean it's the absolute.
So I'm gonna be doing a test probably next summer on that particular topic. I have some Hornady 170 grain 30 cal flat noses around.
Yeah.
From when I first started reloading 38 years ago.
Those are the good ones.
Yeah. And I'm going to be doing a test and looking at how far does the different bullets deflect if you have to run them through a piece of, I'm going to use plywood, I think.
Yeah.
Some sort of plywood or what's the word I'm looking for? Anyway.
Oracle board or something.
Even something like that. I want something consistent. So
Sure.
we'll just do the test and see what happens.
Yeah. He's still at it. He's retired.
Yeah.
And
Well,
he's still
Because
doing it.
and I'll put it on my website.
okay. What's your website?
It's www.bulletology.com. There's a pile of good information there, and it's there for anybody who's inclined to read through it and take away what they will.
Yeah, I've referenced it. We get people that reach out, like they hear the technical podcast stuff, and that's in alignment with their interests, and they want to learn more or consume more, and so they reach out to us and say, hey, do you guys have any other references you'd recommend reading or looking at or whatever? And some of the questions I've answered there, I've sent them, hey, the specific interest you have, that's a perfect spot for it. So there's a lot of good stuff on there.
Well, and there's few publications out there that would have this broad, but also this complex level of information.
Mm-hmm.
I can't think of I think of one rather.
Yeah.
That would be this all-encompassing and in-depth.
Yeah.
So definitely check that out. And Bulletology, BULLETOLOGY.
That's correct.
Bulletology.com.
That's the name of the business, so that's the name of the website. So.
Excellent. Well, I've been there before. I know Jayden sent that article right as you guys got it up online, and I checked it out. And there's tons of little articles that you can read about different specific topics. If you're doing some research.
Covers a lot of different things.
Yeah. Well, another topic that we have covered in the past is kind of the transonic instability gremlins that I talk about.
Oh my gosh, everybody talks about
that.
it.
Everybody blames when they miss a target if it's
1,500 yards away. It's unstable.
Yeah, I missed because of the transonic gremlins or whatever it is. But Jeff, I know you have a very interesting take, and your experience being different than mine. You can explain that in a different way. So maybe give us some insight there.
Yeah. So there are two types of stability. First is gyroscopic stability. Do you have enough spin to keep the pointy nose forward? I think you've covered it on previous podcasts. Mm-hmm. That's a necessary prerequisite for the second type, which is dynamic stability. And that is a matter of, is any bullet yaw going to decrease as the bullet goes down range? If that's the case, the bullet is said to be dynamically stable. So when bullets come out of the gun initially, there's a little bit of wobble. Mm-hmm. People say, oh, that's an unstable bullet. That's not the case. Those bullets are stable. As they go down range, does the magnitude of that wobble damp? Does it get smaller? If the answer is yes, that bullet is dynamically stable. What happens when you do the transonic transition is a change in the Magnus moment from the Magnus force center pressure moving aftward tends to destabilize the bullet. And what happens is the bullet will just fly with a persistent non-zero angle of attack. And that's called a dynamic instability. And it's what happens to one bullet is going to happen to the next bullet to within a very small margin of error. So if the bullet flies with, let's pick a number, 3 degrees angle of attack, it'll be 3 plus or minus a couple tenths of a degree. So if one bullet to the next bullet to the next bullet, you should have very consistent performance. Okay? So that's
That's against the grain from popular shooting culture.
Well, so that can interact with differences in crosswinds.
Sure.
Okay. So there are lots of things that can go on. One of the things that we cover in the book that I hope people who read it take away is the notion of an error budget. There's this much error from this source, this much from barrel, this much from bullet, this much from muzzle velocity, this much from drag. All of those things cause the groups to open up. The nice part about the error budget, you can hang numbers on each of the factors and figure out which one's causing you the most grief and attack that one.
Mm-hmm.
So that's one of the things in the book that I hope readers will use and take away and apply to their particular problems.
Yeah, for sure. It's a very useful concept. I think people will. We apply it a lot, even when we're designing something new, say we're coming out with a new cartridge like 7PRC, when that thing was in its infancy, when it was an idea in Seth's head, we look at things from that perspective. What do we think this cartridge is going to produce for those different metrics, for muzzle velocity and the variability, for the bullet class that it's going to have? What's the drag variability going to be like in that, and the raw drag and all those things? And then we can kind of see a problem coming before we spend all that time and money and investment in actually making them, testing them, and discovering that, right?
Yep.
So taking that aspect can kind of back to what we've covered in prior podcasts of that stuff can save you money, right? If you don't have to just go experience failure after failure after failure, if you can take kind of an analytical approach to it, and if you understand how it works, you can then do that and look at it in a way where you can, like you said, Jeff, pick out those problems before you have to discover them, in the field especially.
Yeah, and that's why a lot of backyard ballisticians, if you will, to speak to your point about the 7PRC, when the 7PRC came out, there's a lot of uproar, and still is. Why didn't you just neck down the 300? I want all the velocity.
Right.
It's like,
They don't understand. That's not how internal ballistic works.
If you sensibly approach it, you can avoid problems.
Yeah,
very true. And just talking about that example right there, just your level of understanding of the topics at hand. In this case, I was going to mention stability, the different types of stability. The way that you can convey that in such a easy to understand conversational manner, everybody can digest that. Because up until Jayden explained it to me however many years ago, which he probably skimmed from you, I had it just trying to find something on the internet that helped me understand it. And this brings these topics to a much larger group of people because now you're not glossing over.
Right. And people say, oh, it's unstable. Does that mean it's going end over end? The answer is no. And nor will it. I got on a Facebook bladder capacity contest with a guy a few years ago, and oh yeah, the bullet's unstable, and he's got bullets sideways in the target, and I was like, looking at the size of the group, it's like you're firing too long a bullet for too slow a twist. You can't fool me.
Yeah,
it's like, and he shut up. That was the end of that.
So I've got a question. You said you've been reloading for 30-ish years?
Yeah.
So in that unique experience you've had, say in doing the large cal work or the long rod work or whatever, was there things that you learned in that kind of alien world, right? That's kind of an alien world from the perspective of small cal stuff.
Yeah.
It's not shoulder fired. I'm not looking through a scope or iron sights, Was there things that you learned there that you applied to those early days of reloading?
I'm so glad you asked that question. So early on, Malcolm Gladwell says you have to have 10,000 hours to be an expert at something. I was just about 5 years in, 10,000 hours into my career as a ballistics engineer. And we got an opportunity to build some ammunition in 30 millimeter for a barrel erosion test. The boss from someplace had managed to scarf some high flame temperature propellant, but it was 155 millimeter. Oh, that's going to be too slow for our application. So what do? We mixed it. Something they tell you, don't try this at home.
Yeah. Leave it to the professionals.
Yeah.
Or the
So-
semi-professionals.
Well, so even at that, there. I mean, and that's we'll get to it eventually, but the approach was let's mix this with some ball powder to something that's quicker, much higher relative quickness to get that hot stuff burning, even though it's the wrong quickness. And if it blows out the end of the tube, we're kind of okay with that. And so that's what we did. We took a steel case, 30 millimeter, which is not standard these days. 30 by 173 is aluminum case. Anyways, we were using a steel case. What I did was I actually sprayed some rubber cement inside the cartridge case to act as an adhesive to keep the ball powder in place. Poured in a small quantity, say 50 grams of the 155 propellant. Sprayed in some more rubber cement. Put in the rest of the 155 powder. Added in another 50 grams. So we're talking, a case that normally holds 150 grams of propellant. I got 170 something grams in there. It's like, there are people looking at this hybrid type trade name, propellant, and that's one of the things that can be done. If you need more energy in the case, you can do that. At any rate, everything was fine until we started crimping the cartridge case. Doubled the pressure. Oops. First time we did that, we had to have the barrel sent back to the shop, have the case machined out, and we started over. This time, crimping every shot before we pulled the trigger on it. So the war stories are in the book for entertainment purposes and to give people the idea that it doesn't matter how big an expert you are, you can run into stuff that you had not thought about or hadn't anticipated, and it might not end well for you.
Yeah.
So.
Well, yeah, when you're doubling pressure.
It was just like that quick,
Yep.
that quick. You went from uncrimped at 60,000 psi to crimped at 120.
Wow.
Well, that's what the transducer said before it crapped out.
Yeah.
No wonder it's hard to pull that case out.
Yeah.
Well, speaking of war stories, there's been a couple given. Maybe tell us a couple of your favorites or those that kind of pertain to the small cow world, since that's most of our audience.
Or before you get there, you mentioned that they're in the book. So just for the listener, within the book, I think it's every chapter, you have a war story about the chapter.
Almost every chapter has its own associated war story. Some of them have two.
Okay.
Yeah.
Where you really learn some lessons.
Yeah. Yeah, so the high velocity test fixtures has a war story, regarding a guy who pretty good engineer, but he for some reason hadn't occurred to him that cartridge case could get pushed above its elastic limit during firing, and almost all cartridge cases are stressed above their elastic limit. That's why we have to resize them, right? Mm-hmm. So this was a custom-made brass cartridge case, and his comment to us was, because it has a lower modulus of elasticity than steel, I don't have to worry about the case getting stuck. I don't think that's right, but okay. And he wasn't part of the ammo group, and he just went off and did his thing, and half dozen shots later, he's creeping up on pressure, and the case got stuck. And this is a case that would hold 3/4 of a pound of powder.
Oh, big. Yeah.
Big case. Yeah. So they had to bring the barrel back to the shop, and they had to turn the case out, and we started over, or he started over.
Yeah.
So, yeah, there are all kinds of crazy tests that have been done. I did a sticker test for artillery. What's a sticker?
Yeah, I was going to say, what's a sticker?
A sticker is where you put the bullet. Now, artillery is a little different than small arms in that you cram the bullet in separately. There's no cartridge case. There's just a bag of powder that you load into the chamber. And you fire it, and the powder burns, and away goes the bullet. Well, the other thing that artillery does is they do what they call zoning. They load less powder in to change the velocity so that the angle of fall provides the smallest impact footprint at the target. So if you're less than max range, you can pick a particular muzzle velocity that gives you the best on-target effects. Perfect, right?
Yeah.
Well, the first job was we had to determine what's the probability of sticking a bullet in the tube at top zone. We don't know. Well, now we got to go do a test. And so it was a binary search, cut the powder in half, fire it. Did it exit the tube? Yeah. Well, cut it in half again. And keep doing that until the bullet no longer exits the tube. Worn barrel is going to be different than a new barrel. We tested both. We did not test an end-of-life barrel, but basically you would stick the barrel in the tube, burn all the powder, and the bullets didn't exit the tube. Like, okay, so now we got to clear the tube somehow. And it turns out there's a procedure for that. Basically, they slide a lever. The primer comes squirting out the back. It looks kind of like a 4570 cartridge case. It's actually a little bit bigger than that, but same idea. Let the gas blow down. You need to be out of the way when you pull a lever. Open the breech, put in what they call the clearing charge, which was kind of a zone 4 or zone 5 charge. Fire it, clear the bullet out of the tube, and start over. It's just amazing how far you can, if you're standing behind the gun, they pull the trigger on a 155 or an 8-inch howitzer, how far you can see that bullet. You can see it to a count of 3.
Wow.
It's just astonishing. You can see that bullet for an awfully long way. There are a pile of other fun things that I did over the years. From a small cal perspective, I think the first one I got involved with was looking at the aerodynamics of wasp-wasted shotgun slug. I think you know what I'm talking about.
Yes.
It's a piece of lead with a piece of plastic crammed up the skirt on the back end. And we ran a yaw card test. We didn't learn a thing. Not so good for the customer, but, it basically what that told us was this thing is not statically stable. It's not gyroscopically stable. How does it work? How much money do you have to go chase that?
So for the listener, when he says yaw cards, that test is essentially if you could envision, say, a bunch of sheets of cardboard back to back to back to back with gaps in between them, and you fire through that, and you're measuring the projectile's orientation at different distances in its flight, and you can kind of get some idea of what it's doing. That's what that test is.
There are pictures of a yaw card setup on my website.
Yeah.
So, yeah, people can go have a look at that. But yeah, it's a way to extract pitching moment, which is a key factor in gyroscopic stability and in dispersion. So it's a fairly simple and inexpensive test to conduct, and I'm a little bit surprised it doesn't get more use.
Yeah, as simple as it is, and available as it is to everybody. Yeah, yeah. Can you? One of my favorite, I guess, kind of war stories is the 22 cal stuff, where the dispersion went nonlinear. Can you tell that one a little bit?
I can. We're not going to mention the customer.
Sure, just generalities and what was observed aerodynamically.
Yeah. So what happened was we were approached. This is over a decade ago by a customer who was working on a non-toxic 22 rimfire projectile, and they said this is a really, really bizarre behavior. We've never seen it before, and it turned out we'd never seen it before either. Basically, what would happen was the bullet would shoot, 2-inch groups at 50 yards, and by the time it went out to 100 yards, the groups were 3 feet in diameter. It was just amazing. I'd never seen dispersion nonlinear to that degree before. I'm like, something strange must be happening here. And we had to figure out what the something strange is. And so what I did was I went and looked through the library of different projectile shapes. I found one that was kind of close and modeled it in the projectile design software and took the results from that, corrected for what was measured, and then ran this bullet that we were working on through it. And what I found out was that at high velocity, when you launch it, say, from a rifle particularly, that bullet would start off with a center of pressure after the center of gravity, which is something that should never happen for a spin-stabilized bullet. It's kind of okay if you're talking badminton birdies or air rifle pellets, but it's something that should not happen for spin-stabilized projectiles. So as the bullet traveled downrange, it would slow down, and the center of pressure location is a function of the velocity of the bullet. And at some point during this flight to 100 yards, the center of pressure and the center of gravity became coincident, which means the bullet had infinite gyroscopic stability, and the bullet would pick a direction and fly off into who knows where.
Yeah.
Okay. So, like, all right, now we've got a handle on what we think is going on. What's the fix? The fix was to make the bullet a bit longer, about a half a caliber longer, so another 100 thousandths long. They built some, they fired them. It was
No problem.
It was exactly what we wanted to happen. And so, like, did they decide to go forward with the longer bullet? The answer, sadly, is no, because it was no longer the fastest rimfire bullet out there. So marketing kind of drove the bus there. No offense intended.
Yeah. None taken, because
Yeah. So
I work for the department, but I know very little.
Yeah. So
You've been on both sides too.
Yeah.
So
yeah. So the bullet, we understood what was happening with the bullet, but we couldn't convince the marketeers to, hey, let us explore this a little more, and we'll get you something that shoots past 50 yards.
Yeah.
And they said, nah, we're good. Okay, whatever. Hey, as long as you're paying me, it's fine.
yeah,
The computational power and the resources that you had to investigate, though, that's incredible.
Yeah.
That's nuts. You know, that's a real job, that this technology exists in the world, and that, you know, these people are available to do this.
Yeah.
That is so cool.
It's the people with the background. It's the test data that's available. Can you apply it?
Yeah.
And from that perspective, I was exceedingly fortunate.
Yeah. Well, that story's uniquely, I think, cool when you think of the analogy of this series we went through on BC-based calculation methods versus forof and the amount of complexity there. That story is a perfect example as to the complexities that are going on with a bullet. It's not just that simple lump of metal flying downrange, and it's just gravity, time of flight, and wind. There's a lot of other stuff going on, and if you don't have those advanced calculation methods, you can't even begin to account for it.
Exactly. Well, and it also kind of loosely proves like forof. It's a free app. Go out there and use it, or get the Kestrel with it.
Right.
Because that kind of computational power that you had to at your fingertips to investigate this problem, that same horsepower is used in forof versus a ballistic coefficient calculator.
Yeah. When you compare those two, it's pretty cool. We just went through a big series or episode with Miles where we kind of broke some ground on sample size stuff and how it's viewed in the commercial, small cal world, or even in the industry too. We talked about that the industry is really as a whole
inundated.
is still kind of based on like 3 and 5 shot groups, maybe 10s and stuff like that.
Maybe 10.
So, Jeff, I know you have a lot of opinions on sample size. I mean, what's your take on what you view as, you pick up a gun magazine and you read an article on a review about a rifle or ammo and you see the data there, and what's your take on all of this?
Yeah, so I got my panties in a bunch over 3-shot extreme spread. I just think that's if you want to sight in with 3-shot extreme spread, have a party. If you're going to do load development, you got to take the bull by the horns, and you got to be pretty serious about your analysis. And used to be you'd plunk the holes in the target, and you'd get the dial calipers out, and you'd measure the X and the Y, and you'd do the standard deviations, right? How much variance in horizontal and vertical do you have? And my opinion, you need to average those two numbers, because if the distribution gets skewed, averaging is more representative of the true dispersion of those bullets. These days, it's pretty easy to get that data. I've been using on-target software, and basically it's you snap a picture with your smartphone of the target, you import it into the program, you click on a couple of references on the target, and that does the scaling for you. You click on the holes, you tell it you're done, you click on the aim point, and it gives you all of the information that you need. And it's not as fast as doing extreme spread, but you get a whole lot more out of it. If you just use extreme spread, you're leaving half the data on the table, and you're not making use of it. What sense does that make?
Yeah.
What sense does that make? Load development, I'm shooting 5-shot groups. And I'm doing sigma X, sigma Y.
Looking at each individual shot.
Individual shot. Yep, that's what I'm doing. And from a error standpoint, how much error is there in a 3-shot group extreme spread metric versus a 5-shot group standard deviation metric? Well, the uncertainty goes from 60% with the 3-shot group down to 25% with the 5-shot sigma. That's a huge reduction.
Just with 2 more shots.
Just with 2 more shots, and putting a little more effort into analyzing your target.
Yep.
Why wouldn't you do that?
Yeah, you shot the 5 shots. Why would you look at just 2 of them?
Yeah.
It's a good point. Yeah. And the podcast that Jayden is referencing, it just launched today, Thursday the 15th, just a few hours ago. So we'll see what kind of feedback we get. But Jayden, Jacob, Miles, the lab as a whole, they've been doing sample size testings of 30, 50, and 100, and adjusting charge weight. Miles has done 50 shots and then move the charge weight, 50 shots, move the charge weight. And he did that with seating depth as well. And the data that we were receiving just opened our eyes like nobody's business. It's like you think you see this trend, but you don't see anything. What you're seeing is noisy data. And by shot 30, everything dampens out.
And that's kind of the dirty little secret. I mean, it takes a lot of shots to have statistical confidence in what you're doing. And I converse all the time with guys. I do my load development, and I do a ladder test, and I look at where the velocity doesn't change much, and that's where I pick my load, and that's all nonsense. That's my opinion. That's all nonsense. The big problem with that is the fact that there is so much variation, shot to shot to shot, in engraving force, that you using that ladder test and picking that, one shot for each charge weight, picking a load based on that is
waste of time.
Thoroughly meaningless, in my opinion. Yeah.
Well, and to speak to that, in the big sample size testing that Miles and Jayden and the lab crew has done, they see that with any given charge weight, the extreme spread standard deviation of the velocity spread is almost always virtually the same, regardless of charge weight. And so if you're picking one, even on a 50-shot sample, and you record 5 of them, it means nothing because the extreme spread is likely not the same, but quite similar all the way across the charge weight spectrum.
Right.
Yeah.
About a year ago, you sent me all that data,
Mm-hmm.
and I had a look at it. And my first impression were, there's not much to pick from here. And then I dug into it a little more deeply, and it took me a long time thinking about it to say, okay, let's go look at this, let's go look at that. Well, by the time I got done with it, I did pick a charge weight that was kind of on the lower end of the charges tested,
Mm-hmm.
that resulted in low muzzle velocity variability as well as small dispersion and small dispersion variability. So those things kind of go hand in hand, in my opinion.
Mm-hmm.
Can you shoot small groups with high muzzle velocity variability? Maybe.
Depends on the range, I suppose.
A short range, yeah.
Yeah, maybe. But, if you're going to go out past, let's pick a number, 600 yards, you better have good, tight velocity variability. Otherwise, you're going to be hating life, man. You
Missing targets like the rest of us.
You won't like it very much.
Yeah.
So
I want to ask you what your acceptable level of accuracy and precision is. That's in the precision rifle game, you talked about the OCW test and people doing load development with these small sample sizes, and they say they have a quarter-minute gun or a half-minute gun, and as Miles and the crew has documented with this large sample size, if your rifle system averages half a minute at 100 yards, it could shoot groups as small as about a quarter minute and as big as like 0.8, 0.9 minutes if it averages a half a minute on a big sample size. So for you, when you're working up something, it sounds like you're a recreational shooter. What's acceptable for you?
I'm most of what I do is for hunting.
Okay.
And so my needs and my bullet selections are a little bit different than the guys who are doing the long range thing. By the way, one time I visited here, I think it was in 2014. Joe Thielen had a pre-production Ruger precision rifle.
Yeah, he did.
And
6.5 Creedmoor.
And and he let me shoot that, and we started at 500 and kind of worked our way up to 1,000. Shooting the 10-inch gongs, and like out to 900. I hit everything first time. Like, wow, this is amazing. This is amazing. Yeah, my standard is, if I can put 5 shots into an inch, I'm happy. I'm using kind of off the shelf. I won't say bargain basement, but kind of off the shelf, non-custom rifles. I have one rifle right now that's in the shop. I'm having a new barrel put on it. It's got a new. I actually went through the hoops to get a new receiver. I don't have the rifle yet. I'm going to get it back in the spring, and I can't wait to shoot it.
What's that one chambered in?
In 30-06.
Beautiful.
Classic.
Yeah. So, looking forward to sending bullets downrange with that one. I've got some rifles with me. I'm going on a hog hunt in February.
All right.
In Texas with some guys in Colorado, and 300 Win Mag.
Cool.
That's what I got.
Can't go wrong. That's a big bullet and a tough animal.
Bring enough gun, I hear.
Yeah. You can definitely go wrong in the other direction. Under shooting a pig is not much fun. But yeah, they're tough for sure. I mean, the armor on the sides of those things is insane.
And there's nothing funner than dropping pigs.
Yeah.
That's a blast.
Will you guys get to use thermal and night vision and stuff, or do you know?
I do not know. But basically, it's my first time doing this, and we'll see what happens.
Yeah. Have you used that stuff before?
The rifle I have only done load development on. I have not shot anything with it. I bought it from a friend from church who was getting on in years, and he and his wife were getting rid of things, and I was like, I'd like that.
Yeah, give that rifle some new life.
Yeah. So he had bought that in Alaska when he was a young man, and he killed caribou with it, and and came with a bunch of reloads that I didn't know anything about, so I promptly disassembled them, and you know, I still have the bullets. Don't know what I'm gonna do with them. You know, still got the powder. Don't know what to do with it.
Put it in the garden, maybe.
Yeah, that's probably where it's gonna end up. So, but I've got some lows worked up, and I'm pretty happy with it. So let me ask you guys some questions.
Okay.
Would you say that it's easier to develop a robust load with a lead core copper jacket bullet, or is it easier to do it with a monolithic copper?
I would say on average, and when I say that, I mean the average barrel and maybe average cartridge and average propellant, right? All those components being average. It's easier with a cup and core bullet, so a copper jacketed lead core bullet. Now, I've seen circumstances, actually hunting season this year, for one of the first times, I had a monolithic style bullet, a CX, outshoot the cup and core bullets that I tried. Now, that's one barrel with one powder, right? I didn't go changing stuff around.
Right.
And we have seen that. We've seen the biggest...
Did you do a direct drop-in or just bullet swap?
Yes.
You did?
Charge
Okay.
weight was fixed.
Okay.
Yep. And both bullets were around the same grain weight, you know, within its class.
Sure.
Yeah, so I would say more often than not, I see a cup and core bullet shoot easier. I'd say when we make bullets too.
Yeah. That's what I was gonna second that.
But that statement is not a distinguishment of, you know, extremes, right?
Yeah.
It's not like you set a bullet press up with a cup and core bullet and you turn it on and it spits out half-minute bullets, and if you do the same thing with a monolithic style, it spits out 4-minute bullets. That's not true.
Yeah.
Right. Right.
But yeah,
I would say I agree with that 100%. In my experience, the lead core bullets have been easier to get to shoot really well than a monolithic bullet, but there are some caveats, and one example would be the 7mm 160 grain CX. Just here recently, I don't know if that's the bullet you were referencing.
it was, yeah.
But in the 7PRC, we made a bullet specifically for the 7PRC. It's 160 grains. It's got a very similar shape to our 180 grain ELD match, but it's just made of monolithic material. And that first lot of bullets that we manufactured, from start to finish and everywhere in the middle, that particular lot of bullets just drove brass tacks. So what I was going to say was, in my experience, the lead core bullets have been easier, but I think from the projectile standpoint, when we manufacture them, a lot of our lead core bullets have a higher accuracy standard before we will qualify a run than a monolithic bullet does. So if you look at our ELDX, our ELD match, our A-tip bullets, those have a significantly better or tighter accuracy standard than a hunting bullet like an SST or an interbond or an interlock or a CX, our monolithic bullet. So just because we see that, I don't know if it's necessarily cause and effect saying that the lead core bullets are in fact easier. It just could be the bullets that we are using.
So one of the things that happens when you pull the trigger on a cartridge is the pressure comes up, and that makes the bore grow in diameter. How much? It's not a lot. It's half a thou maybe on a 30 cal bore at 60,000 psi and a barrel OD of an inch. Most of them are a bit bigger than that, so you expect that deflection to back off just a little bit. Well, bullets shoot like they've got about 2/10,000ths of an inch clearance at the muzzle. So how does it get better as it goes down the barrel? Would be my question. And what happens, I think, is the lead inside the jacket gets smashed from the acceleration and pushed from the pressure, and it causes it to expand on the diameter. And that's what keeps those inbore angles small, which helps you shoot small groups. Okay? So the lead core copper jacket bullets, I think, I hate to use the word inherent, but that's really the behavior, the structural behavior of those bullets is such that I would expect them to shoot smaller groups in a wider range of barrels than I would a monolithic. That's me. Are monolithics horrible? No. They're terminal effects wise, how do you beat them? They're incredible. They're just incredible. Yeah. So if you're shooting long range at paper, lead bullets the way to go. Lead core bullets the way to go.
I think that's an important point that you just made when you said on the average over a wide variety of barrels. So from all the different barrels, all the different guns, and then the manufacturing life of the bullet, because we're not making. Let's say we make a run of 250,000 bullets. Well, that doesn't take us very long, and then you do another run and another run, another run, and another run of all the bullets that we make. On the average of the entire bullet scheme or spectrum and all the gun spectrum, a lead core bullet in a given barrel
is more forgiving.
Yeah,
more forgiving.
Good point.
It's more robust.
Okay.
Yeah.
Good way to put it.
Yeah. Yeah.
That was interesting. It seems to make sense in my head. I can't support it in any way, but it does make sense that it would obturate.
Yeah. So kind of measuring that's a tough thing to do.
Yeah.
Like how do you? I mean, even if you're using flash X-ray to look through the barrel, how do you measure half a thou on a flash X-ray? I don't know how you do it.
Yeah, that's tough.
So,
if I could figure out a way to shrink myself down, Honey, I Shrunk the Kids style, and be able to sit right there next to the throat of the chamber and watch that bullet go by, I'd be the happiest guy in the world.
No, you wouldn't. No, you wouldn't.
Well, theoretically, right?
You'd have
I would get to finally see something that I've wanted to see for a very long time.
You'd have all these propellant grains whacking you in the head.
Yeah, I might need a little bit of protection from heat and pressure, but yeah, boy, I'd sure like to be able to see that.
If you were holding a 6-inch set of dial calipers as you got shrunk down, maybe the large 6 inches would be like a thousandths of an inch,
right,
and then you'd be able to measure things past
I
a half
really
a thou.
figure some stuff out.
Yeah. So one of the things that has surprised me, I guess, of lately is the notion that there's an optimum powder for a given cartridge. Like, is it? And I know there's an interaction between the powder and the primer, and plus other things in the chain, if you will. So if there were no resistance pressure on the bullet, the powder that you'd pick in terms of the least amount of velocity change for a given charge weight change, the powder that you would pick would be the slowest powder available, right?
Right.
But since there is resistance pressure, some of these slower powders behave like they have higher relative quickness for that particular application. So I started looking at that. I'm like, how the heck does that happen? I think I know why. It's back to the 155 stickers. I think what happens is the bullet starts moving down the barrel and it gets crammed into the forcing cone and starts to engrave, and that slows the bullet down. And then that causes the rate of volume generation behind the bullet to decrease, and that causes the pressure to spike.
Mm-hmm.
Okay. So when you go to a loading manual, I always pick the powder when I have powder available.
Yeah.
That's a whole nother problem.
No kidding.
Uh-huh.
I always pick the powder that gives me the least sensitivity in terms of changing the velocity for a given amount of powder. I want the lowest velocity change for the powder charge difference between min and max. That's the way I do load development. That's my procedure.
So to put it another way, what you're doing is you're taking the difference in let's pick two charge weights. You take the difference in the velocity that those two produce, and then the difference in the charge weights, and you do that for all the powders.
That's
and you
right.
divide it out, and you pick that. What
You
would
pick
be the
least sensitive?
would it be the highest number?
The lowest number.
Lowest number.
Lowest number.
Yeah.
Here's a question for you. Do you consider single-based or double-based or extruded or ball propellants in that, in your experience? Do you use those as considerations?
Yeah, I think it kind of pretty much depends on what I'm going to be using the ammunition for. And I don't have any particular bias either way. I do the let's look at the slopes,
Mhm.
and I'll pick the one that gives me the least sensitivity.
Okay.
And for a batch that just loaded up 30-06, 178 grain cup and core bullet, I picked a ball powder.
Okay.
Okay, and I trickled them. So I've got not exactly, but almost exactly the same powder weight for every cartridge. I do it with extruded powders. I don't have any particular biases. So
well, I do, and I was hoping you'd have some insight. And I don't have the background, or I worked in the lab for a little bit, but I don't have any supporting evidence other than the anecdotal stuff that I've seen. When I'm looking for accuracy, extruded powder, no questions asked. And I don't know, I've seen that duplicated in my, again, anecdotal field results over and over and over again, doing some of the load development when we have a new cartridge, or when we're going to have a new ammo SKU. So you work the loads up, whatever, and you try to get a certain amount of velocity within the given pressure, and you also have an accuracy standard.
Yep.
If accuracy is paramount, like on our Precision Hunter ammo, for example, extruded powder was the no-brainer. Jayden could maybe speak to that. I was hoping you might have some insight there.
I got some thoughts, but let's hear what Jayden has to say first.
Yeah, I'd say those trends definitely exist, and especially from a historical context. That technology is always changing, right? In the same way
propellant technology.
In the same way that we're creating new projectiles or cartridge designs and releasing them, that's happening on the propellant side as well. But usually it doesn't make as big of a splash, right? A new bullet or a new cartridge makes a pretty big splash in the shooting community. But you do see new propellants coming out, and in the last couple of years, you've seen some new ones, like from Hodgdon, the Stayball 6.5. Traditionally, the ball powders were viewed as being more temperature sensitive, right?
Mm-hmm.
They would change more when it was cold out or hot out. Your velocity would change more. So that realm used to definitely be owned by the high class extruded powders. I would say that some of the ball powder technology, it seems to be starting to target those areas traditionally held by the legacy extruded powders. Not to take away from those, they're still, they're tough to beat. They've been that way for a very long time. That's a whole interesting realm itself. Probably something that you've had experience with is how long some of those powders have been around. Some of those powders that came out of DuPont, not long after the turn of the century, and they're still around today.
4831.
Yeah, a lot of those old IMR series powders.
3031.
Yeah,
they've been around forever.
Yeah.
A lot of the group size variability is likely tied to what we would call action time variability. Is the time between primer strike and bullet exit consistent shot to shot to shot?
Mm-hmm.
Does the pressure rise look consistent? All of that is tied up in what size group you're going to shoot. Making the powder burn out before it exits the tube, that's a big deal. You don't want to. I heard you talk to somebody once upon a time about showering the back end of the bullet with a hail of
ejecta
unburned powder, and you're absolutely right. Where does it hit last? What effect does that have? That's absolutely a player. Is the flame spread through a bunch of spheres more consistent, or through a bunch of right circular cylinders with a hole through the middle? Or is that more consistent? I don't know the answer to that. I wish I did.
Yeah.
I wish I did. With the pressure measurement equipment that you folks have, there is lots of information to be learned. The problem arises in, if you had a transducer at the mid case and at the case mouth, could you measure, say, pressure waves in the case? Pressure waves are a very, very bad thing. They in large and tank ammunition, they've been shown to cause breech blows. So what happens is ignition shock runs through the propellant bed, hits the projectile, bounces off, and now when it gets back, it gets amplified, and instead of 70,000 psi, it's 120,000, and
Out goes. Yeah.
yeah, and it never ends well for the tank crew. So that's something you want to avoid. They take great pains to avoid that. We have the same problem in small cal? Not so much. Not so much.
Yeah.
The new propelling charges for artillery, they're what they call modular. Each prop charge is made out of combustible case material. It's basically, you can think of cardboard, but with nitrocellulose in it, so it burns up when the powder charge burns. It's got very strategically placed ignition components and strategically placed propellant components, and you can just stack them up. And if you need a zone 2, you load in 2 increments. If you need a zone 3, you load in 3. You need 5, you put in 5. It's actually very interesting, intriguing approach to changing the velocity for artillery.
Sounds pretty. Yeah. That's.
So we're not there in small cal.
Yeah. Not yet. Anyway. Get to work, Jayden.
Yeah, I'm on it. Okay,
Yeah.
I'm on it.
Let Jeff retire. You need to take over and get on it.
You mentioned the word inherent a little bit ago,
With a cringe.
I hate that
you
word.
bit your tongue just a little
Oh,
bit.
yeah.
What do you got to say about inherent?
Okay, let's talk inherent. Lots of people say, "Oh, that cartridge is inherently accurate," and I'm. If you're viewing from 30,000 feet, inherent might be a word you'd use. But in my experience, every single interface parameter and some parameters unique to the cartridge case, some unique to the propellant, some unique to the barrel, all influence the size groups that you shoot. And so, I mean, you guys know from 6.5 development, 6.5 Creedmoor, you got to keep the throat in the barrel tight to keep control of the bullet. Does that make it inherently accurate, or did you make a decision?
We designed it that way.
There you go.
Right.
There you go. So, low variability in bullet mass. Is that important? Depends on what you're doing. Low variability in charge weight. I think everybody's on board with that. Low variability in cartridge case internal volume. Yeah, absolutely. Because that's going to affect the peak pressure that's developed and the resulting muzzle velocity. Absolutely. So I'm in one of the slides in the classes I used to give says there's no such thing as inherent accuracy, and I'm still on board with that.
Sure.
Is it more robust? Absolutely, and it's more robust because of the engineering decisions we've made with regard to the barrel, to the bullet, to the powder, etc.
Yeah. So maybe a better way to say it would be by nature of its design, or
there you go.
Yeah.
There you go.
I told you I didn't work for marketing, but trademark that.
Yeah, but design and manufacture.
That's
a key there. Yeah, you got to do it right. You can design it right and screw up the manufacturer, and doesn't matter what you did with the design.
Yeah.
Mm-hmm.
That's a good point. Well, Jeff, this book, it's helped me a lot. I still reference it to this day in my professional capacity. Seth, it's helped you
a ton.
What do you hope people get out of it? Because so the book is Ammunition Demystified, and the subtitle is The Non-Bubba's Guide to How Ammo Really Works.
Yeah,
that's a pretty direct statement.
That is a pretty direct statement, and I've caught some flack for it in some circles, and I guess I don't care.
They should check their ego. We talked about that before.
Yeah. So in my book, the Bubba is the guy that just puts something in a firearm and says, "Oh yeah, let's pull the trigger and see what happens."
So the book isn't for that guy.
It is not
that's
for that.
satisfied with that experience. There's nothing wrong with that experience. If that's how you want to do things, great.
Get after
But
it.
if you're the guy that wants to know more, you want to know why. Is that who you wrote it for?
This is really the how and the why, and not the what.
Okay.
Less of the what. I mean, you want a reloading recipe. There are much better books. I don't have any in there.
Yeah, we've got a great cookbook right here.
Yep.
Yeah, all kinds of recipes.
Yeah, this is more of this is how the cartridge cases work. This is how the propellants work. This is how the bullet works. This is how the statistics work.
Yeah.
For you or against you.
Mm-hmm.
Yeah.
I think the internal ballistics portions, that's something that nobody has a good handle on. I say nobody as a general term because obviously that's not the case, but large scale, general consumer, passionate shooter, passionate reloader, really into it, studies this, stuff up, not his job, he just, that's what he's passionate about.
Yep.
There's not a good place to get a lot of good internal ballistics information.
Yeah.
That's modern,
Right.
There's some stuff that I read years ago that was printed many years ago, and that helped give me a good frame of reference. But there's very, very few resources on internal ballistics that I would call are from an expert.
And in-depth resources.
Yeah.
Like if you have the Hornady reloading manual and you read those first 100 pages, there's a great, foundational knowledge block in those first 100 pages. If you finish that up and you're like, man, I wish this would have kept going and got deeper, that's Jeff's book. Yeah, that's where you need to go.
Yeah. From an analogy perspective, you can think of extruded powder as slices of a log, and you put a hole through it, right, with an auger bit or something, and the bark on the outside is the deterrent layer, okay, and only it's the deterrent layer is all of the exposed surfaces, and when you pull a trigger on a cartridge, the primer exhausts this hot, we can call it flaming particle-filled gas into the propellant bed, and it strikes that deterrent layer and lights it off and gets it going. Ball powder is different. It's, Willy Wonka's never-ending gobstopper. It's a layer upon layer upon layer of stuff, and that stuff can be a little bit more temperamental in terms of ignition. Okay, that might be part. Yeah, so you might do an experiment. You get a cartridge and you get similar loads of ball powder versus extruded powder. What happens to the velocity variability? You use, 50 cartridges of the ball powder, 50 cartridges of the extruded powder. What's the velocity variability look like for those two? Is it the same? I don't know. You got to do the test.
Yeah.
Got to do the test.
Never ending.
Yep.
It's a good thing.
Yeah.
Good problem to have.
Keeps me occupied.
Yeah. Not like you don't have other stuff to do as well. I could see little bits of gray coming into your beard.
Yeah. The hair's still falling out of my head, but the beard is still strong. So I'm doing all right.
All right.
Yeah.
Well, you mentioned it at the beginning of the podcast, talking about all of your mentors and then your attempt to teach people. You want to go on any other detail about why you wrote the book, or what possessed you to do something crazy like that?
Well, I was. This was 10 years ago. I started it, and it was like, what? I'm crowding retirement pretty hard here. I better put some of this stuff down, because once I leave, that information's gonna turn into vaporware, and nobody have access to it. So I figured let's write it down and see where it goes. All of the feedback I've had so far has been very positive, and freely admit that most of the people who've bought the books have been engineering types.
Yep.
But I think it's written at a level that the dedicated hobbyist will be able to digest it and take away good information from it.
Yeah. Well, it's definitely a service. You provided a service to the industry for sure, and not just the engineering types and those that are in the industry, but the dedicated hobbyist as well. It is. We're glad you shared that information, because it's again, I'm trying to think of another publication besides McCoy's book, but how old is that?
Yeah, and that's heavily concentrated on exterior ballistics.
Yeah.
I mean, the book is titled Modern Exterior Ballistics.
Yeah.
There's some other very, heavily technical,
Yeah,
good ballistic.
Carlucci's book
Yeah,
is
absolutely.
a good one. I mean, very good one.
Yeah.
And that could I have written one of those? Yeah, probably not.
Would
But
you have wanted to write one of those?
no,
Yeah, exactly.
no. There's there are a few equations in here. I've had some friends I've given the book to. Oh yeah, there's a lot of equations in it. Like
Not if you've opened those
there's
other
really
books.
not. There's really not a lot of equations. But it was the book I would have wanted when I was starting out.
Perfect.
That's a
That's
great way to put it.
That is.
Yep.
Yep.
I've learned all of this. I mean, things like gain twist rifling. That we could do a whole podcast on that.
Mm-hmm.
It's very commonly used in medium caliber. Almost every gun that I can think of has a gain twist. It's not used in small cal, generally speaking. Why? It's harder to make. It's more expensive. I mean, it's just, doesn't. Large cal? Let's just say I did some work in large cal in the relatively recent past, and it's being evaluated. But it's something that's way different than anybody else has ever built before.
Cool. Technological advancement. I like
Love
that.
Well, let's hope so.
Yeah.
Let's hope so.
Yeah.
Let's hope so.
Awesome. Well, Jeff, for everybody here at Hornady, for everybody that's going to read the book, and for everybody that's benefited from your work that was kind of largely done behind a curtain, obviously a big thank you.
Yeah. So the book's available on Amazon and Barnes and Noble.
Okay.
And it's also available at an ebook format. So if you don't want a hard copy laying around the house, you
I'd
have that.
say
have
get
that
both
option.
for the low cost of what an ebook is.
Yeah.
Have both, because it will end up being a technical document if you get the book and you digest it and it's like, okay, that's a lot, but that was really good and I'm glad I had that. Having it in the digital format.
Yeah, it's
can be
easy to
really
search,
helpful.
Like
Yeah.
You go through it and say, hey, I want to go back and review that part about this. You can type that in.
Yeah, there is a cross reference in there, so it's relatively easy to find things.
Excellent.
Even like things like when the angel pisses in the propellant.
Oh, yeah. Yeah.
Was that a war story? I don't remember that part.
That's in there.
And the hammered owl poop. That's one of my favorites, too. The battery won't die on that book, so that's nice.
Yeah. Yeah, that's awesome. And actually, this is anecdotal and tangential to our conversation, and I'll make this brief, but I thought about the war stories and I thought about this book within the last couple months that I was still working in ballistics before I left for marketing. I was doing some load development on something, and we have these experimental propellants, and typically if there's an X at the end of it, that means it's just slightly slower burning than the name. So, give it a name, 295. 295X would theoretically be slightly slower than 295. And in this instance, it's not always the case. And I didn't check, and I tested it anyways, and pressure went from 58,000 to, transducer stopped at 105. Yeah.
Oops. I hate it when that happens.
Yeah. So that was one of my last uh-ohs. But I thought of those war stories in the book because it's like, oh, you know what? I probably won't forget this because I don't know what the actual pressure was, but I've never touched off something that hot.
Yeah. I mean, I've my last high pressure incident was probably a decade ago, and it was one of those deals where I picked kind of a mid-range load to start for a monolithic copper bullet, and first two shots were kind of it's a little hard to slide. It was a Brugger number 1. It's kind of hard to open the breech. Third shot, I opened the breech and cartridge popped out, and there was no primer. Oops.
Yeah.
Oops. So that was the end of that.
Yeah. Luckily, my experience was in a test barrel, so I was behind a glass door and pushed a button. But
no harm, no foul.
Yeah. But I remember having that thought when I looked at the computer and went, "Ooh, better write that one down, not to do that again." Jayden, you got any last questions for Jeff while we got him and the record button still pushed?
I don't think so. I hope that Jeff coming on the podcast and especially writing that book. Thank you for doing it. Getting that written in stone for those to come. As you're in your own words saying you wish you had that book when you started. I was fortunate enough to have that book in some of my early days, and it helped tremendously. And I hope that benefits the listeners to this podcast. I hope they gain something. But anybody in the future that gets that fire of ballistics in them, I would recommend that.
Awesome.
Thank you.
Yeah, thanks, Jeff. Everybody out there in podcast land, hopefully you enjoyed this interview with one of the living legends in ballistics. He's been instrumental in so many things that we've done and that have been done in the study of ballistics. We're grateful for everything he's done and to be friends with him. And let us know your feedback. Hit us up at podcast@hornady.com or drop us a comment, and we'll catch you on the next one.